In this video, we're going to look at sentences of PL that contain quantifiers. So this is what we've seen so far. This is the vocabulary of PL that we've seen, and we've seen how to construct atomic sentences out of it and then truth functional compounds of atomic sentences. The last two elements of the vocabulary of PL are the quantifier symbols. And these are used to construct quantifiers so what you do is you pair them with an individual variable, right? Lowercase x through z, um, and then enclose them in parentheses. So these are examples of quantifiers here. Now remember that by informal convention, you can usually substitute square brackets for parentheses, but now this does not apply to quantifiers. Quantifiers are always in round parentheses, not square brackets. What a quantifier does is quantifier says how many objects in the universe of discourse a statement is true of. And there are two types. So if you have a quantifier of this form, the upside down A, and now remember what this is, right? This boldface X, this is a metavariable that refers to any individual variable, right? So any variable ranging over objects in the universe of discourse. A quantifier of this form is called a universal quantifier. And if you have this in front of a formula of PL, what this means is that that formula is true of every object in the universe of discourse. It corresponds to words in English like all, every, any, etc. The sort of conventional way of saying this is for all x, or whatever variable you have, right? If you had a w there instead, it would be for all w, etc., etc. That's just the traditional way of saying this. So let's go back to the symbolization key that we've been working with, and we'll look at some examples of sentences that have universal quantifiers. So every sentence has every city has a professional sports team. Right. For this, what we want is X has a professional sports team, right? So it's going to be P of X. We're going to need a variable in there because we're talking about the entire universe of discourse. And then what we want then is a universal quantifier in front of it. So it's going to look like this. For all X, X has a professional sports team. Every city is smaller than Miami. This is going to be basically the same sort of structure, except we're going to be using this two-place predicate here. And one place in that is going to have the constant Miami in it. So it's going to look like this. We have here X is smaller than Miami, and then the universal quantifier in front of it. So what this says is, right, for every X in the universe of discourse, every city in North America, all of those cities are smaller than Miami. The second type of quantifier is called the existential quantifier. And what this means is that the formula that it's in front of is true of at least one object in the universe of discourse. So the first one, right, the universal quantifier says that the formula is true of every object in the universe of discourse. This one just says that it's true of at least one. And the way that this is usually read is there is an X. Or again, whatever variable you have, right? If it's a Y, then it would be there is a Y, etc. What this corresponds to is things like at least one, there is a, or some. So we can look at some examples of this, right? So some cities have more than 1 million people. Here we're going to have the predicate more than 1 million people. We need a variable in it because again, we're ranging over the entire universe of discourse. We're not talking about an individual object. And then we'll have an existential quantifier in front. So it will look like this. There is an X such that X has more than 1 million people. There is a city that Reykjavik is north of. So here we've got the two-place predicate, X is north of Y. One of the places is going to be occupied by U for Reykjavik. And then we'll have an existential quantifier in front. So it's going to look like this. There is an X such that Reykjavik is north of X, right? This is, of course, true, right? Reykjavik is north of most cities in North America. Remember that order matters. in predicates. So there is a city that is north of Utqiagvik. This is going to be the same thing, except we're reversing the order of these. So it becomes there is an X such that X is north of Utqiagvik. And this is false, actually. Utqiagvik is the city in North America that is the furthest north. It's actually further north than Iqaluit. Last one we'll look at here is just because this is sort of interesting, right? Is Utqiagvik is north of every city. This one is going to take a universal quantifier because you have this every here, right? So that tells us that what we actually want is a universal quantifier. So it's going to look like this. For all x, x is north of Utqiagvik. The reason I wanted to bring this one up is because of the fact that this one is also false. And the reason is that the universal quantifier, remember, says that this here is true of every object in the universe of discourse. So what this says is that Utqiagvik is north of every city in North America. And the problem is Utqiagvik is a city in North America, which implies then that if this were to be true, Utqiagvik would have to be north of itself, which isn't possible. So this is actually false. Now, the choice of variable that you use when you're symbolizing quantified sentences doesn't matter. So if you look at all of these, right, all these different choices of variable, remember the variables can have numerical subscripts. These all mean exactly the same thing. They all just mean some cities have more than 1 million people, right? The particular variable that you use does not change the meaning of the sentence. And same thing is actually true in your symbolization keys. I mean, when we set up this symbolization key, I just used X's and Y's and Z's because that's sort of an easy way of doing it. But the choice of variable doesn't matter. You can use any variables here that you want, and it doesn't change the meaning of the symbolization key. What does matter is that the variables have to match. So the variable in the quantifier has to be the same as the variable in the predicate that it's quantifying over. There is an X, M, Y with mismatched variables, or there is a Y, M, W, right? Because of the mismatched variables here, you can't interpret these inner formulas in this. And so these are actually not even sentences of PL. Another thing that's important to remember is that when you have quantifiers need to include variables, but not constants, right? Constants don't go in quantifiers because constants and variables are two different things, right? So you can't put you can put the variables, right, W through X inside a quantifier. You can't put the constants A through V in. So this is not a sentence of PL because you have a constant in here. And note that it's still not a sentence, even though the symbolization key didn't assign a meaning to A, right? We didn't say what city that stands for. It doesn't matter. It's still a constant. So that's not a sentence. Another mistake that students will sometimes make is think that when you have a sentence about a particular object, that you want to have a quantifier in there. So Utqiagvik has more than 1 million people. They would think that the way that you symbolize this is something like for all Utqiagviks, they all have more than 1 million people. And there's only one. You can just call it by name. So it would just be MU, right? It doesn't get a quantifier because you're not talking about the entire universe of discourse. You're just talking about one object in it. So that's the basics of quantified sentences in PL.